We're going to do something a little bit different here. We're going to tackle a vaping myth. This one's regarding charging a device by USB versus current rating of the adapter, the USB adapter. Now, the myth is basically that people are worried, or might guess, that the current rating of the adapter being higher than the device you're charging can lead to damage or overcharging or just generally bad things, device getting hot, charging too fast, all that sort of stuff. Now, spoiler alert, it doesn't. So it doesn't matter. Basically, this is the answer. Whether it's 1 amp, 3 amp, 5 amp, 10 amp, it doesn't matter. So basically, the device is what determines the charge rate, and we're going to go through that, and we'll talk about why, and then we'll actually test it and prove it. Because a lot of people do ask this question. I see it asked a lot, and the replies are, people try to be helpful, but often, no, it's just kind of scaring people and saying, you can't plug it into a 3 amp supply, it'll blow up. And yeah, it's just not true. So we'll start with the fact that the rating on your adapter, the current rating, it's not what it puts out all the time. So this isn't a 3 amp in everything connected adapter. That's not what that means. All this means, when you see, in this case, 3 amp, or the Apple ones are 1 amp, it means that's the maximum of the supply. So the most these guys are rated for is 1 amp. The most this is rated for is 3 amp. So if your device, and the key point here being the device itself is what determines the charge rate, this can put out up to 3 amps if whatever you've connected is trying to draw that much. That's the gist of it. As far as the devices are concerned, and we're talking about just regular USB here, there are some variants like the quick charging, fast charging, different voltages, stuff like that. We're talking regular garden variety 5-volt USB, which is the vast majority of vaping devices. Anything that you buy, it's got a charging port on it, is regular 5-volt USB. So as far as the device is concerned, if you plug, say this Caliburn, you plug him into the Apple 1 amp adapter, or the ComSol 3 amp adapter I've got here, which is also QC compatible, or the 6 amp adapter I've actually got under the bench, it doesn't know that any of these, the current ratings, doesn't know. It doesn't know this is 1 and this is 3 and that's 6. All it sees is 5 volts. So they're all just 5 volt supplies. You can think of it as just a dumb source of 5 volts, and it's entirely up to the device to draw what it wants from the adapter. Now, the only time the device you connect can tell the current rating is when it's too low for what the device wants. So, say for example, I plug this guy in, that's trying to charge at 2 amps. You plug that into the 1 amp adapter, it will be limited to whatever the maximum of the adapter can put out. When they say 1 amp or 3 amps, that's their nominal rating. Now, any decent adapter of like good quality, they're going to be capable of doing what they're rated at or more. So often you'll find Apple adapter, or I think this ComSol, it's not a bad brand. It wasn't cheap. You'll find they will put out more than what they say. So I know for a fact that the Apple adapter will put out 1.3 to 1.4 amps. This guy was closer to 4. The one under the bench was a co-op brand, some weird brand, 4-port big guy I've got under the bench. It would put out about 8.5 amps. So yeah, way above what they're rated at. So you can't rely on the adapter to limit the current basically at what it says. So it's not putting that out all the time. It's not current limited at that level what it says, and you wouldn't use it. You shouldn't ever use it to basically limit to that current. Now, another reason why you wouldn't actually want to try and use the adapter current rating as the limit of what you're charging at is because then it means your adapter is running absolutely flat out. And when you're charging the adapter and the device, it's a system. So you might take this guy for example and say, oh, I don't really want it to charge with 2 amps. I think that's a bit too much. I'll plug it into a 1 amp adapter, and the whole system will then just run at 1 amp, and that's great, that's safer. It's not though, because this is trying to draw 2 amps. It won't be able to. It'll end up drawing whatever the maximum of this guy is, 1.3. Then your adapter is going to get hot because it's running at full capacity or over its rated capacity. And what can happen is, well, first of all, what will happen is once any of these supplies get too close to their maximum, the USB voltage is going to start to drop. So you're pulling that 5 volts down. As you reach that limit of what any supply can put out, you're going to sag that voltage down. And you don't really want that. Like, it is allowable to go down to 4.4 volts on a 5 volt USB, I think is the official spec. But first of all, you don't really want to be doing that. And second, what can happen is they will start to shut down. So the adapters themselves will hit their current limit, and they can actually completely drop out their output. So you can see these guys, when they're overloaded, literally drop off to 0. And you'll have a period where it'll sit there at 0 volts output. Basically, it's shut off the output, and then it will kind of reboot itself, restart the switch mode supply, and then you'll get your 5 volts back, which again will get pulled down because whatever you've connected is trying to draw too much, and it can just loop like that. So you just constantly just maxing out the supply shutting down, waiting, coming back up, and then getting maxed out and switching off again. And it's not good for the supply. It's not good for your device either. There's just no reason to do it. So as a rule of thumb, you always want and this is in other electronics as well, you generally always want your supply to have more capability than what you need to draw from it. So I don't like using car analogies, but it's like having like wanting to go on the highway at 100 kilometers an hour. Having a car that is absolutely flat out at 100 kilometers an hour, it's just not good for it. Going to be, hard on everything if you that's literally its top speed, and you've just got your foot on the floor holding the thing at 100k an hour, just pinned. Not good for it. Now, obviously, if you've got a car that can do 160 or 180 k's an hour, and you're sitting there 100, it's just cruising along. It's chill. It's all good. Pretty much the same thing with the adapters. Just because the car can do 180 doesn't mean as soon as you get in it, you're going to do 180 everywhere. It's going to force you to do that. You being the operator, and in this case the device kind of being the operator, can choose what speed you want to go at. Let's plug these in and I'll actually show you. So this is the lowest current device I've got at the moment that's working, and I think it's around about, I don't remember, 700-800 milliamps, 700 to 800 milliamps, something around about that, nominal. So what we're going to do is super simple. I've got a special USB cable here that I've intercepted the positive wire on, and it's going through the ammeter. So we're going to see exactly what current's flowing through this USB plug. We're going to plug each device in, and we'll just look at what current they're drawing. Pretty straightforward. So let's start with the Apple adapter. And I've done a test on this where basically I just kept putting heavier and heavier loads on it until it dropped out. And it was around about 1.4 was the maximum I could draw out of this guy. So we'll plug in our Caliburn, original Caliburn, 0.76, 763-ish milliamps into the 3 amp console. 762 milliamps, 763, exactly the same. And you'll have to take my word for the big USB supply that's under my bench here. It is hardcore double-sided taped up under the desk. I'm not pulling it out. Anyway, it tested at about 8 amps, bit over, about 8.5 amps. So plenty of current out of that guy, if required. And 763 milliamps, so literally to the milliamp, exactly the same. 8 amp supply, 3 amp supply, 1 amp supply, the Apple one, wherever I put it, exactly the same. So this device, doesn't matter what, if you plugged into any, it's going to charge at exactly the same rate. It's not going to be damaging the battery. It's not going to be getting hotter. It's not going to be doing anything differently if it's plugged into any of these adapters. So it's not like, oh yeah, you can plug it into that one, but it's not good for it. No, it just doesn't matter. It's exactly the same. It doesn't care. Okay, next device. The Geek Vape Aegis Mini that I've been using lately. I don't even know what this charges at normally. We're going to go reverse order into the 8 amp supply. We're drawing 1.29-ish amps. 1.27 on the 3 amp. And the old school Apple adapter. 1 amp rated Apple adapter. 1.29, so happily drawing well over the 1 amp. Now I don't have a voltmeter on it at the same time, but you would find that the voltage is starting to sag down a bit. It'll be well below 5, well not well below, but it will be below 5 volts. Probably sitting at something like 4.8 or something, 4.7. So if I were to leave this charging on the 1 amp adapter, this guy's probably going to start getting hot. But again, it does depend on the actual brand. And a good brand should be able to sit there at close to its maximum and not get raging hot. But if you're using a cheaper, crappy adapter, those things can get super hot. Like they can get scalding hot, like over 100 degree, Celsius component temperatures inside is definitely possible for the cheaper units if you're running them flat out. So in this case, we're actually seeing that this guy's drawing a little bit more out of the lower rated 1 amp adapter, and it's not much. We're talking like 30 milliamps, 40 milliamps, something like that difference between all of them. What you find is, depending on the adapter itself, some of them will hold their voltage up a bit better. So you might find that the Apple adapter is holding its closer to 5 volts better. I know the Co-op brand, the big 8 amp adapter I've got down here, even though it's 8 amps, it does seem to sag down a little bit. It sort of hits the 4.9, 4.8 pretty quickly under light load, but it will hold from then on up to 8 amps. And that little bit extra voltage, a little bit extra current, but it's essentially the same. But counterintuitive, on the 1 amp supply, we're actually charging at 40 milliamps higher than any of the other adapters, the 3 amp or 8 amp. Okay, Smo-Ant Dual 18650. Let's plug this guy into the 1 amp Apple adapter. And we're drawing about 1.2. Okay, on the 3 amp console adapter. And a bit under 1.16. And into the Co-op brand adapter that I've got under the bench, the big 6 amp, 8 amp rated guy. Pretty much exactly the same, 1.2 amps. And you can see that's actually just varying around because of the regulation on the board is kind of a bit up and down how it's charging the battery. Jeez, I'm struggling to find any dual 18650 mods that are still working with a micro USB. They're all my new ones are all USB-C. Random Woody Vapes X200. Basically, all you need to know is it's a dual 18650. And 1.67 or so. 1.68. 1.7. Yeah, it varies around a little bit. That's on the 6 amp, 8 amp under the bench supply. Now we'll go to work our way back down on the 3 amp console. We've got 1.6 something, 1.6454. Basically the same. Okay, on the 1 amp Apple USB adapter. Now, what are we going to see here? Ooh, it's not charging at all. It shows it's charging, but it's not. Struggle Town. Yep, Apple adapter did not want to charge, does not want to charge this at all. So the device actually says it's charging. Kind of seeing little pulses of current. So if you've got this plugged in, that's a very dark screen, probably not going to be able to see that. It's showing the charging animation. And I can see pulses of current going on here. because this is wanting to draw 1.7 amp and this is flat out at 1.3, 1.4. It's trying to start up and then it's seeing this load and just going no. Now some mods, when they're seeing a very low USB voltage, kind of they don't draw as much current at that point, so that you can kind of get away with using a lower rated adapter. Or you might get this situation where you'd think it's charging, it looks like it's charging, but look at the ammeter, it's doing basically nothing. So you got a situation where this adapter is trying to fire up, it's trying to bring up that 5 volts, and then there's this huge load. It knows it's too much load and it drops the power out. So this would take forever to charge if it even ever got fully charged, even though it thinks it is still plugged in. Bugger all current flow. Yeah, so that's what you get when you use an adapter that is too low. No good. Last one we'll try is the Freemax MaxPod. Something slightly newer than all this ancient stuff I've got out tonight. I've even got, check this out, E-Leaf iStick 50 watt. This is the one that was renowned for burning people's houses down with the faulty charge circuit, internal battery. I actually took it apart. It's really good inside, apart from they just undersized one component, but let's not talk about that. On the Apple USB adapter, 730 milliamps or so on the MaxPod. And that's going to be a fairly typical current range for the pod devices, around about 500 to 800 milliamps or so. .3 amp console adapter, 730 milliamps. Big ass adapter under my bench. We got 730 milliamps. So again, even with a small pod device, this guy does not care where it's plugged in. 1 amp, 3 amp, 6 amp, 8 amp. Doesn't matter. It's going to charge exactly the same. Exactly the same. Okay, so someone's probably going to say, yeah, but that's just for the devices you've got here. It could be maybe my mod doesn't limit its own current and it will charge at the full 3 amps. Now, I can't guarantee for every single device in the history of anything you could buy vape related and plug in, but it's just, you, from a design point of view, you can't have the current regulation left up to the supply. It's just, you can't do it. It's would be the most irresponsible, horrific design you've ever heard of. They know you put a USB socket on there, that means you can plug it into any adapter. So there's adapters you can buy, again, just even from what I've got on the bench. 1 amp, this guy down here will do 8 amps. You know, they know you've got a lead that's got a USB plug on the end. You can plug it into any of them. Now, if you've got a device this small and you've got a cable that will plug into a huge high current supply, you can be assured someone's going to do it. And if that happens, something's going to explode. You know, they can't just let devices go out into the wild that can be plugged into supplies multiple times higher than what they could possibly withstand charging at. It's just not how things are done. So while, no, I can't guarantee if you find the crappiest, cheapest, most horrible device that it might try to max out the supply, I can't see it happening. I've never seen anything even that remotely bad. I ordered some of these horrifically bad old Ego threaded pen things from, you know, eBay or bloody wherever, $5 each, something like that. Even these things don't care. I'm going to try and find the charger for this. I'll prove it. Aha! I found it. Now, technically, this guy has no charging circuit in it at all. It's this little screw-in dude. That's actually the charging circuit. And you can tell by input 5 volts, output 4.2, and that's what the batteries are. All lithium batteries, single cell, maximum charge of 4.2. So, these things are just utter garbage. They're just so cheap. Literally, I think between $5 and $10 Australian for the charger the kit, the whole kit, the battery unit, the atomizer. I think it even came with a spare atomizer with the old silicate cord in it. I don't know if you could buy a worse, cheaper device than this. Like total no name off. I think some of them were off AliExpress, some were off eBay that I got. I got a whole bunch of them to test. Let's see if these guys blow up. Okay, supposedly this is maximum 420 milliamps output. I doubt we're even going to see that, but let's give it a shot. Oh, no, I can't. What am I thinking? Damn it. I need to go through the ammeter. Crap. Okay, I've had to butcher a cable because obviously it's not micro USB. I couldn't use my little spliced cable thingy for the ammeter. So we've butchered this cable. Well, that's fine. I've got another 6 of these things. And we're going to plug this into... First of all, we're going to plug it into the Apple. I've lost both leads already. Look at the copper. There's almost no copper in here. Nothing to clamp onto. And we are charging 300 milliamp. 330 milliamp. Whoa, we're smashing. Around about 360 milliamp. 3 amp console adapter. Oh, it doesn't like that one. 130 milliamp, 170. It doesn't know what it's doing. Oh, this thing's garbage. Actually, I noticed this before when I was testing it. It dropped off really quick. Only charged at a high current right at the start. So far we've gotten 300 something milliamps out of the 1 amp adapter and 170 out of the 3 amp. 140. It doesn't know what the hell it's doing. Oh, and I can't get to the 6 amp adapter. Won't reach. Too small. Okay. But that'll prove the point. And yeah, you can see it didn't go up to 3 amps, didn't go up to 4 amps, whatever. Didn't go up to even 1 amp on the 1 amp adapter. So the cheapest, crappiest e-cigarette device that I know of still doesn't overcharge on a 3 amp adapter. So I don't know if you can find something that maxes out the supply to charge. It's just I don't think it's going to happen. I don't think there's one in existence, to be honest. Okay, so what did we learn here? Just doesn't matter. Doesn't matter which adapter. Now, the only one caveat for that is in the case of the device having a failure of the charge circuit, like unrelated to obviously the amount of current going in, because we've proven it doesn't matter. It's the same on any adapter, but there's always a chance of failure for a charge circuit, any charge circuit in anything, in your phone, in your rechargeable vacuum cleaner, in anything. So say for example the charging circuit has a problem. There's a really small case, a really small possibility that being plugged into a much higher current adapter could make a problem or a failure that's already happened on the device kind of worse, because there'd be more current going through the failed circuit. Now, that'd have to be in the case where something actually shorts through the charge circuit or shorts internally in the charge circuit. Like, we're talking like a proper component failure in the on the board. Charge controller or a MOSFET or something has actually failed and is kind of shorting the adapter. Now, is there going to be any sort of safety difference between 1 and 3 amps going through it? I don't know. I mean, I think if you put 3 amps through it, a small shorter component, it's going to fry the component and just turn it into an open circuit pretty quickly anyway. And it's such a small chance of failure for it to fail in that particular way. You'd often have a charge circuit, if it stopped working, you plug it in, just nothing happens. It'd have to fail in that exact way to cause a short circuit onto the power supply. And then also, if it is a proper short circuit, these are just going to shut down anyway. We saw it actually when we tried drawing 1.8 amp out of this guy. It just turns off. I don't know. It's such an obscure combination of failures that you could maybe get more current through a completely failed charging device while it was plugged in, but I don't know. I personally don't think it's worth worrying about. I don't think there's any reason to avoid a high current adapter at all. It just doesn't make any difference. And even in a failure, I would struggle to see it's going to make any tangible difference. We can also say that with this guy being a QC charger, QC 3.0, capable of switching to 9 volts or 12 volts. It's a newer charging technology that uses a higher voltage and a lower current, but overall higher power to charge. And it's got a protocol in there to. It's got to have basically a handshake with the device it's talking to, so it's got to do things to the data lines on the USB for that device to say, "Hey, I'm a QC capable charging device. Can I please have 12 volts?" Essentially, and this thing hears that and goes, "Oh, yep, that's cool. I'll switch to 12." Now, that is, if this were to accidentally switch to 9 or 12 volts, the voltage is something that can definitely fry your device. If you somehow patch 12 volts into these guys, into any normal 5 volt USB device, it will fry it instantly. It will stuff it. Absolutely no questions asked. These are made to have all normal 5 volt USB devices plugged into them. Now, if you want to be super careful, just use a regular 5 volt only device for 5 volt only supply. Like these guys are just a fixed 5 volt. Then you're sure it's always going to get 5 volts, but I think these are fine. I've used these for every charging test. I've plugged every different device in. I've never had it erroneously switch to the higher voltage, which is exactly, it's designed to not switch to a higher voltage unless it's completely in agreement with the device that's connected to. So yeah, when we just saw it didn't make any difference to the current either. So what have we learned? It doesn't make any difference what current adapter you use. It's not going to overcharge. The rate at which your device charges at is not governed by what it says on the current rating. This is just a maximum of what the supply can put out. It will not make your device charge too quickly or charge hotter or shorten the life of your battery or any of that sort of stuff. So if you've got a 2.4 amp, say, is quite a common size you get with phones and stuff like that. Got a 2.4 amp adapter and you want to charge your pod on, yeah, plug it in. Just doesn't make any difference. Go for it. Yeah, that's about all I've got. So so I hope that's kind of cleared that up a bit and you can see some actual testing and numbers behind it. Cool. Thanks for watching. Cheers.